of the session. In the earlier sessions on Laplace transform, we concentrated on what is a Laplace transform, how to find the Laplace transform of some basic function, properties of Laplace transform, and some theorems related to Laplace transform. So in this session, we will concentrate on wave synthesis and Laplace transform of waveforms. So to find out the Laplace transform of the given waveform, we need to synthesize the wave. Actually, wave synthesis means it is writing the mathematical expression for the given waveform. Because to find out the Laplace transform of the given waveform, we need to identify the mathematical equation which represents the waveform. Then only we can take Laplace transform. So first step is, for the given waveform, we need to write equation, mathematical equation. So first, procedure to write equation for the given waveform. Now, for any waveform given, how to write the equation? Now, these are some of the steps which I framed. So first, check the magnitude at t equal to 0. Now, at t is equal to 0, what is the magnitude? And if magnitude is a, then add a u of t. This is the first step, checking the magnitude at t equal to 0. Then check the slope of the line starts from t equal to 0. After finding the magnitude, check the slope of the line start from t equal to 0. If the slope is m, then add m t u of t. M is the slope, m t u of t to this. Now next, what is the next step? Identify the point t on t-axis at which slope changes. So identify the point t at which slope changes. Then calculate change of slope. Let it be d. Calculate the change of slope and add dt minus capital T u of t minus t. Because this slope, difference in slope starts from capital T. So add dt minus t u of t minus t. At the same time, calculate change in a magnitude, if any. Change in a magnitude of two lines. If it is b, then if at all it is existing, there may not be change in a magnitude. If there is a change in a magnitude b, then add b u of t minus t. Repeat the steps 3 to 6, means once again. Identify the point t at which slope changes, then calculate change of slope and until slope and magnitude of the line is 0. So this is the general procedure to write the mathematical equation where waveforms consist of lines. So let us see some problems by applying these steps. Find the Laplace transform of the waveform. So suppose for the time being, given waveform is something like this. This is the tau and this magnitude is v. And suppose this is f of t. And this is given as t. Now, what is the step 1? What is the step 1? Check the magnitude at t is equal to 0. Magnitude at t is equal to 0 is 0. So nothing to add. So f of t, nothing to add. Then what is the second step? Check the slope of the line starts from t equal to 0. So this is the slope of the line which starts from 0. So what is the line? Slope of this line. Slope of this line is v V by tau. V by tau is the slope of this line. Change in y by change in x is the slope. So slope of the line is V by tau. So add V by tau t u of t. Correct? Initially no change in magnitude. The line starts from 0. So identifying the slope of the line. So V by tau t u of t. Then what is the next? Identify the point where slope changes. So in this, slope changes at t equal to tau. At t is equal to tau, slope changes. What is the change of slope? D. See, this is the slope of the line V by tau, and this is the slope of the next line. Correct? So this is the slope of the next line, 0 slope. So what is the change of slope? 0 minus V by tau. So change of slope is minus V by tau. So identify the change of slope. So add minus V by tau t minus tau u of t minus tau. Correct? After identifying the change in the slope, add slope, change in the slope, t minus tau u of t minus tau. Check, is there change in a magnitude? Yes. What is the change in a magnitude? Magnitude changes from V to 0. So change in a magnitude B equal to new magnitude minus volt. So it is minus V. So add minus V u of t minus tau. Then once again check the change in a slope. So now there is no further changes. Same time this magnitude as well as slope is 0. This line magnitude as well as slope is equal to 0. So this is the expression for f of t. That is, once again I will write f of t equal to V by tau t u of t minus V by tau t minus tau u of t minus tau minus V u of t minus tau. Now find Laplace transform. F of s equal to, what happens to Laplace transform of V by tau t u of t? V by tau is a constant based on the linearity property. It becomes V by tau into Laplace transform of t, that is 1 by s square. Now what happens to this? Minus V by tau, it is a constant, t minus tau u of t minus tau. So f of t minus tau u of t minus tau, what is the Laplace transform? E to the power minus tau s by s square. E to the power minus tau s by s square minus V is a constant, u of t minus tau, that is e to the power minus tau s by s. So if I take V by tau s square outside, V by tau s square outside, so 1 minus e to the power minus tau s minus tau s e to the power minus tau s. So this is the Laplace transform of the given waveform. So I simply followed the steps which I have defined. Based on the steps of what I have defined, based on that I have written f of t expression, then apply Laplace transform to this. We will see one more problem. Find Laplace transform of the waveform. It is given as tau by 2, this is tau, and this is 1. So f of t. Now, what is the, we will follow the steps again and again. So this f of t, what is the first step? Is there any change in a magnitude at t is equal to 0? No. It starts from 0 only. So a u of t cancelled, no need. So now next, check the slope of the line start from the 0. This is the line which starts from t equal to 0. So what is the equation of this? What is the slope of this? Slope of starting line. Slope is 1 by tau by 2. That is 2 by tau. Slope is 2 by tau. So what I need to add? 2 by tau t u of t. T u of t. Then identify the point where slope changes. So point is tau by 2 is the point where slope changes. So what is the change in a slope? D equal to. Change in a slope is equal to, what is the slope of this line? Slope of this line is change in a magnitude divided by change in a x-axis, change in a y by change in x. So 1, 0. So minus 1, 0 minus 1 divided by tau minus tau by 2. So which is equal to minus 2 by tau. Oh, sorry. Slope of this line is, slope of next line is minus 2 by tau. So what is d? Change in a slope. Minus 2 by tau minus initial slope 2 by tau. So that is equal to minus 2 by tau minus 2 by tau. So what will become? Minus 4 by tau. Correct? Minus 4 by tau. So this is the change in a slope at tau by 2. So what happens? I need to add minus 4 by tau into t minus tau by 2 u of t minus tau by 2. U of t minus tau by 2, t minus tau by 2, u of t minus tau by 2. Now, what about next? Is there any change in a slope? Okay, is there any change in a magnitude at this particular point? No, it starts from the same point. So, b is equal to 0. Now, whether the slope of this line is 0? No. So, once again there is a scope. Change in a slope. What is the change in a slope now? 0 minus minus tau by 2. So 0 minus, this is the slope 0 and this is the slope minus 0 minus 2 by tau. Slope of this line is this, so it is d is equal to 2 by tau, and this change of slope takes place at t is equal to tau. So add 2 by tau t minus tau u of t minus tau. So now change in a slope I took, and what is the change in a magnitude? This magnitude is 0 and finally is also 0. So after this, what is the line? This is the 0 slope line as well as 0 magnitude. So this is the expression of f of t. This is the expression of f of t. So what happens f of s? Once you get a f of t, then it is easy. So it is 2 by tau into 1 by s square. Tu of t is 1 by s square minus 4 by tau. What happens to this? E to the power minus tau by 2s divided by s square plus 2 by tau e to the power minus tau s by s square. This is based on shifting property. So in this, if I take 2 by tau s square outside, so I will get 1 minus 2 e to the power minus tau s by 2 plus e to the power minus tau s. So 1 minus 2 ab tau s by 2, this one. So this I can write as 2 by tau s square into 1 minus e to the power minus tau s by 2 whole square. So this is f of s. So this is Laplace transform of this waveform. So we will say furthermore, next, find the Laplace transform of the waveform. Tau plus a 2 tau, and this is v. Now in this case, since the signal is continuous, we need to check whether the signal is periodic. So now if I observe this signal up to here is periodic. This signal is repeating. So the given signal is periodic with period tau and fundamental signal f1 of t is A tau. This is V. So this is F1 of t. So if the signal is periodic, identify fundamental signal and then apply procedure to write the equation for this fundamental signal. So now here I'll apply the concept. F1 of t is whether there is a change in a magnitude. Yes. What is the change in a magnitude at t is equal to 0? It is V. So VU of t. Add VU of t. What is the slope of the line starts from t equal to 0? This is the line which starts from t equal to 0 and the slope is 0. So you need not add. Slope is 0 means 0 t u of t we have to add. So I will not consider. Next, what is the change in a slope? This is 0 slope. This is also 0 slope. So change in a slope is 0. So I need not add the equation. Now is there a change in a magnitude? Yes. What is the change in a magnitude? Magnitude changes from V to 0. So change in a magnitude is minus V. At what point? T equal to A. So V into U of t minus A. Now whether the slope and magnitude of the line is 0? Yes. Slope is 0, magnitude is 0. So this is F1 of t. So now what is F1 of S is? F1 of S is V by S minus V U of t minus A. So e to the power minus As by S. V into e to the power minus As by S. So I can take it as V by S into 1 minus e to the power minus As. This is F1 of S. But actually we need to find Laplace transform of this waveform. So f of S equal to, based on the properties of Laplace transform for periodic signal, it is equal to F1 of S minus F1 of S divided by 1 minus e to the power tau S. So here periodicity is, period is tau. So this. So what is F1 of S? V by S into 1 minus e to the power minus As divided by 1 minus e to the power minus tau S. So this is the Laplace transform of f of S. This is the Laplace transform of f of S. Now, next, find the Laplace transform of the waveform. Now here it is not a straight line. It is a sinusoidal waveform up to tau by 2. So in this case I cannot apply the same procedure because it is not related to straight lines. So in this case how to write the equation. Now as it is the sine wave, a part of the sine wave. So how to obtain this? So this waveform is equal to this is tau by 2, this is tau. So a sine wave with magnitude V and period t, plus to this I will add another waveform, sine wave of magnitude V but starts from t equal to tau by 2. So same signal but a shifted version. If I add these two signals, what is the result? Up to 0 to tau by 2, it is a sine. Then here it is 0, so sum is same. Now after that, tau by 2 to tau, this is negative sine wave, this is positive sine wave. So cancels and becomes 0. From tau to 3 tau by 2, this is negative, this is positive, so it is 0. So the sum of these two results in this. So this f of t equal to, what is this? V sine omega t plus V sine omega t minus tau by 2, because it is a shifted one. Now the question is, what is omega? Omega is equal to 2 pi f, or it is equal to 2 pi by t, time period. So what is the time period for this waveform? It is tau. So omega is equal to, for this particular problem is, it is 2 pi by tau. So if I substitute this omega in this equation, it becomes V sine 2 pi by tau t plus V sine 2 pi by tau t minus tau by 2. Now what is the Laplace transform of this? Now you got the expression, so write the Laplace transform. So V sine omega 2 pi by tau, so it is equal to omega 2 pi by tau divided by s square plus 2 pi by tau whole square plus V into, this is the shifted signal, so e to the power minus tau s by 2 divided by, tau s by 2 into 2 pi by tau omega by s square plus 2 pi by tau whole square. So this is equal to V by s square plus 2 pi by tau whole square, if I take outside, as well as 2 pi by tau in the numerator, it becomes 1 plus e to the power minus tau s by 2. So this is a Laplace transform of given waveform. Okay, other than the straight line, if it is a sinusoidal, then we need to analyze like this. So we will solve more problem on this in the next session. Thank you.